Hi there, it's me again. I'm back with a new series of videos. For this series of videos, we'll be dealing with grade 11. Now, we already dealt with grade 10, and I hope all of you have passed grade 10 successfully. And for those of you who have not, you can always check out my videos. Now, we dealt with grade 10, and for this new series of videos, we'll be dealing with grade 11. And hopefully in the future, we'll be dealing with grade 12. Before we begin chapter 1, which is about motion in one dimension, I would like to revise some stuff. So in chapter 1 in grade 10, you learned about unit conversion, okay? There were some units and there were some prefixes that you memorized, and you will be needing these prefixes throughout grade 11 and throughout grade 12 too. Okay, so we had mega, which was equal to 10 to the power of 6. Okay, then we had kilo, which was equal to 10 to the power of 3. Then we had centi, which was equal to 10 to the power of negative 2. Then we had milli, which was equal to 10 to the power of minus 3, negative 3. Then we had micro, which was equal to 10 to the power of negative 6. We had nano, 10 to the power of negative 9. And then we had pico, which was equal to 10 to the power of negative 12. Now, these are some of the common prefixes that you'll be dealing with most in grade 11 and grade 12. So how do we change them? Okay, how do we convert from one prefix to another? Now, let's say you have 13 kilometers. You are asked to change that kilometer to meter. Okay, so how do we do this? You see, we have kilo here. You already know kilo is equal to 10 to the power of 3. Now, whenever you have a prefix, remove that prefix and put powers of 10 instead of it. So remove that kilo. We have 13 times 10 to the power of 3. What's the final unit? Meters. That is how you change from kilometer to meter. Okay? Now, let's take another example. This time you're asked to change 9 microseconds into seconds. How do you change that? As you see, we have micro. Okay? As I told you, whenever you have a prefix, an SI prefix, remove that prefix and put powers of 10 instead of it. You know, micro is equal to 10 to the power of negative 6. So 9 times 10 to the power of negative 6. What's the final unit? Seconds. Okay, you get the idea. What if it's the opposite way? What if this time we are asked to change a unit and put a prefix, an SI prefix, close to it? Okay, let's say you're asked to change 33 meters and change them to millimeters. Okay, how do you do that? So look, we don't have any prefixes here. It's meters alone. So whenever you add a prefix to a unit, okay, this here, meter here is a unit, and we are adding millimeters to it. We're going to say what? 33 times 10 to the power. We know milli is equal to 10 to the power of negative 3. So we're going to say 33 times, not 10 to the power of negative 3. When you are adding a prefix, always put powers of 10 oppositely. If it's 10 to the power of negative 3, I'm going to write 10 to the power of 3 millimeters. Okay, let's take another example so you understand better. Now, let's say you have 120 grams. Change that to kilogram. Okay, so 120 times kilo is equal to 10 to the power of 3. Okay, And I told you, when you're adding a prefix to a unit, put the powers of 10 oppositely. So it's going to be 10 to the power of negative 3 kilograms. Okay, and that's it. When we want to change kilometers per hour to meter per second, we have to divide the number. Let's say we have 35 kilometer per hour, change that to meter per second. Just divide the number by 3.6, okay, and you get the final result in meter per second. If you have meter per second this time, you are changing it to kilometer per hour. Just multiply the number by 3.6. Let's say you have 12 meter per second, and then you are changing that to kilometer per hour. Just multiply 12 by 3.6. Okay, and you're gonna get the result in kilometer per hour. Okay, that is how you change meter per second to kilometer per hour, and kilometer per hour to meter per second. Okay, you should also revise units of time. Okay, let me quickly revise. So let's say you have, before that, we know that 1 minute is equal to 60 seconds. Okay, 1 hour is equal to 60 minutes. 1 day is equal to 24 hours. Okay, so if you're asked, for example, change 7 days into, let's say, seconds. Okay, it's pretty easy. We have 7 days times 1 day is equal to how many hours? We have 24 hours. And then 1 hour is equal to how many minutes? It is equal to 60 minutes. 1 minute is equal to how many seconds? It is equal to 60 seconds. Multiply them and you should get the result. Same thing for years. For example, you are changing 2 years into seconds. We're going to say 2 times 1 year is equal to, and let's write that down, 1 year is equal to 365 days. Okay, and 1 century is equal to 100 years, 1 decade is equal to 10 years, and all of these. So if you change 2 years into seconds, you're going to say 2 multiplied by 365 days. 1 day is 24 hours, so multiply by 24 hours. 1 hour is equal to 60 minutes, so multiply by 60 minutes. 1 minute is equal to 60 seconds, so multiply by 6 seconds. You multiply them and you get the result, 2 years in second. Okay? And that is how we do unit conversion. Make sure to revise this because it's going to be really important in grade 11 and grade 12. And you have to be really comfortable when you are converting units. You should have no problem at all because in questions, you're going to be, for example, given kilometer. You should directly change it to meter. You don't have to waste time on that, okay? Now, we have chapter 1, motion in 1 dimension, or motion in a straight line, okay? Now, before we talk about motion, what is motion? Let's talk about something which is called frame of reference. You can already understand the idea from the concept. It's called frame of reference. It is something we refer to when we are doing measurements in physics, when we are talking about the position of an object, when we are talking about the displacement, velocity, acceleration, etc. in physics. Okay? Imagine with me, please. You are in a place where it is totally black or it's totally white, whatever color you like. Let's say it's totally green, it's totally red. Doesn't matter. Just bear with me for a second. If you are in a place where it is totally dark, it's totally white, the only thing that you have is a cell phone. Now I call you and I tell you, where are you? Will you be able to tell me, where are you? No, because it's all white. Okay, if you tell me I'm in a place where everything is white, I'm not gonna understand anything from you. Okay, so let's say this is you. Okay, you are in a place which is all white. Okay, now what if I add something? What if I add a house? Okay, let's say this is a house. Okay, this is a house. Now you can say that I am close to a house. Let's say you know the distance too. You're gonna say I am 3 meters away from that house. Okay, I am 3 meters away from that house. Now I get something. Okay, so frame of reference is just some coordinate system, or it's a fixed point that we want to know, or we have to know, to measure the position of an object, or to measure the location of an object, to know the location of an object. Here, if there wasn't a house, I wouldn't know where's your location. Okay, so let's come back to reality. Everything you see around yourself can be a frame of reference. Okay, maybe you have a door in front of you. You are 2 meters away from that door. Okay, you have the washing machine. Okay, let's say you are 6 meters away from the washing machine. The washing machine is a frame of reference. It is something we referred to when we talked about your location. Okay, so we need frames of references in physics. Otherwise, everything is meaningless. Motion is meaningless. Displacement is meaningless. Distance is also meaningless. Okay, if we don't have frames of references, then everything is meaningless. When you are sitting inside a car, how do you know you are moving? You look at outside, okay, and you take, for example, a building as a frame of reference. As you go, by the way, frames of references change. Okay, let's say you cannot see that building anymore. This time you're going to see a tower. You're going to make that tower your frame of reference. You see another car, and you make that car your frame of reference. Okay, but it should be fixed. Okay, it should be a fixed point. It should be a fixed object. So frames of references can be anything. They can be trees, they can be buildings, they can be an apartment, anything. Okay, so you get the idea. So motion is the change in position of an object with respect to a reference point. Okay, and frame of reference is basically a coordinate system that we use to know the location of an object. Now we have displacement. Before displacement, we should also know what is distance. Let's say there are 2 houses. This is your house. This is your friend's house. Okay? That's the best I can do. I'm sorry. Okay, now, let's say this is A and this is B. You are trying to get to your friend's house, but it's not a straight road. So you're going to do what? You're going to go here. He told you to buy him some stuff. You're going to buy that stuff. Let's say this is a shop. Okay, then you come here, you come here, and you come here. And then you reach your friend's house. Okay, let's make that a straight line. Okay, it's better. So let's say this is 1, 2, 3, 4, and 5. And you reach the friend's house. Here, let's say this is the shop, the distance from your house to the shop. So let's say this is 3 meters. Okay, then here you also covered 3 meters. Here also 3 meters. Here 3 meters. And here 1 meter. Okay, what is that? This is the distance that you have traveled. This is the distance that you have taken. 1, so this is 3. Here we have 3 meters too, so this is 6, 9, 12, and then we have 13. The distance you took, the distance you traveled is 13 meters. Okay, that is the distance between the two houses, or not the two houses, that is the distance you traveled. Okay, so every step, when it comes to distance, we count every step. Okay, now what about displacement? Displacement, we can say, is the shortest distance between the 2 points. So we make a straight line, okay, and in displacement, we can also say it's a straight line between 2 points. Okay, so we're gonna say A to B. That is my displacement from A to B. Let's say it is equal to 8 meters. Okay, we can make that kilometer, okay, because it's going to be more reasonable. I'm going to make that kilometer, and then 8 kilometers. So displacement is the shortest distance. So if I ask you, what is the displacement between A and B? You're going to say it's 8 kilometers. What is the distance that guy or you travel? It is equal to 13 meters. If you turn around the whole world, okay, you go to USA, you go to Germany, you go to France, you go to Italy, you go to Spain, you travel all these countries and you go back to the same point, okay, displacement is going to be 0. But the distance is all the distances you covered, okay? So imagine this guy decides to return home, okay? So he goes back home, let's say he goes back home. This time, displacement is going to be 0. Because if he doesn't change his position, then we're going to say it's going to be 0. So for displacement to happen, we should have change in position. Otherwise, displacement is 0. Now, displacement is a vector quantity, which means it has direction and magnitude too. I can say 8 kilometers to, let's say, north. Okay, I can say 8 kilometers to east. I can say 8 kilometers to south or to west. Okay, it doesn't matter. It has a direction. And it can be negative too. Displacement can be negative too. And we're going to deal with that too. But distance is always positive. It can never be negative. Okay? And it's a scalar quantity. We don't need direction for that. We don't need direction for distance. Okay? I'm sure you got the idea. To calculate displacement, delta x is equal to x final minus x initial. Okay? So let's say most of the time we have cases like this where we have a straight line and we have an object moving on that straight line. Okay, let's say it's x-axis. Okay, x here and then negative x here. Let's say 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So you have 1, 2, 3, 4. 4 is enough. Negative 1, negative 2, negative 3, negative 4. Okay, so if we have an object, let's say it goes from 1 to 3. Okay, this 1 becomes x initial, this 3 becomes x final. So to calculate let's say this is in meters, the distance, the unit here is meters. Let's say we want to know the displacement that object took. So we're going to say delta x is equal to x final minus x initial. This is going to be what? This is going to be 3 minus 1. So the displacement is equal to 2 meters. Okay, positive 2 meters. This positive indicates that this object goes to the right direction. Okay. What if that object, this time, it's not going this way, but it's going this way, let's say 2, and then it stops at -2. Okay, so 2 is x initial. It's the first position. Second, we have x final. You can make it x2 minus x1, it doesn't matter. So to calculate the displacement, we're going to say x final minus x initial. X final is equal to -2. Don't forget that. Then we have another negative, and then 2. Okay, positive 2. So the displacement is equal to -4 meters. That negative indicates that the object is going to that side. Okay, it doesn't mean that something is decreasing or increasing. It just simply means direction. That is how displacement can be negative, because it's a vector quantity, but distance cannot be. Okay, now position, we also talked about that. It's the location of an object referred to relative to a reference point. Distance is the total length of the path followed by a moving particle. Okay, as you see here, displacement is a straight line. Distance is all the the total distance is all the distances that the object has taken. What's the full length that something takes? Displacement, this is the difference between displacement and distance. It's really important. Displacement is the shortest straight line path between two starting and ending points, okay, with direction, of course. The total path length traveled by an object regardless of direction. This is distance. Displacement is a vector quantity. It means it has both magnitude and direction. Scalar quantity, distance is a scalar quantity, which means it only has direction. It has magnitude, with no direction. Displacement can be negative, it can be positive, or it can be 0. Okay, distance can always be positive, or it can be 0. Okay. We also talked about this. Make sure to take a good look at this one too. We have average velocity. Okay, average velocity is what? Average velocity, average velocity is equal to delta x divided by delta t. It is the distance, it's the speed at which, or it's the distance at which an object travels in a unit of time. Okay, let me give you a simple example about average velocity. I'm sure you have been to 120 meters road. That system works in Kurdistan nowadays, which is you have two radars, okay? We call them cameras, speeding cameras. One is here and the other one is here, okay? They have put a time, okay, which is an average time, of course. You should go by that average speed, otherwise you're going to have a speeding ticket. Let's say on the 120 meters road, we know that the average speed is 110 kilometers per hour. If you go 120 kilometers per hour, then you're going to have a speeding ticket, okay? But that average velocity, we can do something, okay? We can say, I'm going 90 kilometers per hour here, but then after that, I'm going, let's say, 120 kilometers per hour. So it's going to be the same. That's what you mean by average velocity, okay? Now, let's solve some questions about these. Before that, we know that velocity is a vector quantity. It has both direction and magnitude. And it can be measured both in kilometers per hour or mile per hour, okay? Now, we have question, sample problem 1a. During a race on level ground, Serdar runs with an average velocity of 6.02 meters per second. Okay, so let me erase that. Okay. Now, Serdar runs with an average velocity, so V average is equal to 6.02 meter per second. Okay, what is Sardar's displacement? So delta x is equal to what after 137 seconds, if time is equal to 137 seconds, or delta t. Okay, now you know the equation for average velocity. We have average velocity, which is equal to delta x divided by delta t. We don't have this. We are trying to find delta x, so it's going to be delta x is going to be, just cross multiplicate them. Delta x is going to be V average multiplied by delta t. V average is equal to 6.02 times delta t, which is equal to 137. This equals 6.02 times 137. We have 824.7. We're going to say 825 meters. Okay, that is the displacement that Sardar takes. Okay, that is section 1. In the next video, we're going to be solving practice 1A. Make sure to comment below and subscribe to my YouTube channel. If you have any questions, please make sure to comment below. See you in the next video.